Hello, Algebra 2 students. Today I want to talk to you about the end behavior of polynomial functions. And that's referring to how a graph behaves, a function f of x, as x approaches positive infinity or negative infinity. In other words, what does it do at the very ends? How does the graph of that function behave at the very ends? So farthest to the left, this graph is up. Farthest to the right, this graph is up. So we would say its end behavior at the far ends, as x approaches negative infinity or positive infinity, we would say that end behavior is up, up. What about for this? We would say the end behavior is down, down. For this graph, we would say the end behavior is down, up. And for this graph, we would say the end behavior is up, down. So I'm going to see if you can figure out what it is about a function, a polynomial function, that determines the end behavior. And here's a big hint: is it has to do with the leading term. What is a leading term? We talked about the leading term in a previous video about putting polynomials in standard form. When a polynomial is in standard form, the term with the highest power on the variable, the highest degree, goes in front, and that term is called the leading term. So see if you can see a connection between the leading terms and the end behavior of these four graphs. Pause the video and think about that. Pause the video and see if you can come up with a connection between the leading term of these polynomial functions and the end behavior of their graphs. Pause, see if you can find a connection between the leading term, what it looks like, its attributes, and the end behavior of the graph it generates. In the final end behavior possibility, pause and see if you can see a pattern here and compare to the other patterns. So it does have to do with the leading term. Specifically, it has to do with the degree of the leading term and also the sign of the leading coefficient. So let's look here. Here we notice that in each case, the leading coefficient has a negative out front. And in each case, the degree is even. When the degree of the leading term is even, the ends will be even with each other. They'll go in the same direction, but because the coefficient is negative, they go down, down. So notice every one of these polynomial functions has a negative coefficient on its leading term and an even degree on its leading term. So the end behavior is down, down. Notice here, on every single one of these polynomial functions, there's a positive coefficient on the leading term. The sign is positive out front, but the degree is even on that leading term. And whenever the degree is even, the ends will be even with each other, but the coefficient's positive, so they end up, up. All of these functions have a leading term that has a positive coefficient, but an odd degree. Whenever the degree on the leading term is odd, the end behaviors will be at odds with each other, going in different directions. And if the coefficient's positive, it'll end on a positive note, so it'll be down, up. If you notice in this case, every one of these polynomial functions has a leading term that has a negative coefficient, a negative out front, and an odd degree. If I took this binomial and FOILed it out 13 times, the leading term would be negative x to the 13th. So it would have a negative coefficient and an odd degree. Whenever that leading term has an odd degree, the ends will be at odds with each other. And whenever it's negative, a negative coefficient on the leading term, then it'll end on a down note, up, down. If you forget that that's the rule, then just go back to the most basic odd degree function that you know. In Algebra 1, you learned about linear functions. And you realize, well, here the lead term is positive and the degree is 1, which is odd. So, and I know that line, I know how to graph that line, and it goes down, up. And then you can remind yourself, oh, odd degree on my lead term, even positive coefficient, down, up. And you know how to graph y equals negative 2x from Algebra 1. And if you did a little sketch of it, you would remember, oh, negative coefficient, odd power, end behavior is up, down. Likewise, earlier in Algebra 2, or possibly in Algebra 1, depending on your program, you learned about parabolas. And you could just sketch them, the two most basic, to remind yourself of the pattern. Oh, y equals x squared. I remember how to graph her. And I see that the leading term has a positive coefficient, even power, even, the ends are even with each other. Positive coefficient, they're up, up. And negative, I know how to do y equals negative x squared. The coefficient is negative. Here's my leading term. Coefficient is negative. Even, the ends are even with each other, but negative, they're down, down. So now practice. Pause the video and try to figure out what the leading term would have to be like to have this end behavior here and here. Up, up, positive, even. Down, down, negative coefficient, but even degree on that leading term. Pause and try to decide what would my leading term in the polynomial be that generated this graph with this end behavior. Down, up, ends on a positive note, positive coefficient on the leading term, but odd degree. The ends are at odds with each other. They go in different directions. Pause and again, if you haven't, and decide what will this leading term be on the polynomial that generated this graph. And behavior's up, down, ends on a negative note, negative coefficient, but the ends are at odds with each other. They go in different directions, so odd degree. Let's go in the other direction. Looking at this polynomial, these polynomial functions, figure out what would the end behavior be if I was trying to graph this guy. We're going to look at our leading term, positive coefficient, odd degree on my leading term. And so I know that if odd degree, the ends will be at odds with each other. Positive, it'll end on a positive note. Down, up, down, up. Here, who's my leading term? Here's my leading term. Even degree, the ends will be even with each other. It's negative, so it'll be down, down. Pause, practice, and then press play. Who's my lead term? Negative, odd. The ends will be at odds with each other, and it's negative, so it'll be up, down. Pause, describe the leading term for the polynomials that generated each of these graphs, and then press play for the solution. Up, down, negative, odd degree. Down, down, negative, even degree for that leading term of the polynomial whose graph is represented here. Pause, describe the leading term of the polynomial, that what it has to be like in order to generate the end behavior you see. Up, up, ends are even with each other, even degree, and they go up, positive. Positive coefficient, even degree on that leading term of the polynomial that generated this graph. How about this one? Down, up, ends on a positive note, positive coefficient, but the ends are at odds with each other, odd degree on the leading term. That is how you figure out your end behavior on polynomial functions. So I'll leave you with these adorable puppies and wish you a great day.